Okay, so we are going to continue on with Daniel Walker. He will be talking about the offline mapping of assets with our GIS module.
Thanks, Kat. Good afternoon, everyone. My name's Daniel Walker. I'm a developer at DataSplice. I've been with them for coming up on 5 years now. And one of the things I've spent a lot of time working on over the last couple of years are mapping. Many of our customers have GIS servers as one of the systems in their network. Using DataSplice, as I'll show you this afternoon, it's possible to consume data from one or more GIS servers and allow your functional folks out in the field to perform their work from the point of view of a map. I'm going to actually switch to another window here briefly. So on my screen right now, what may be familiar to some people in the room, for those who haven't seen this kind of thing before, this is a Esri web service listing a bunch of different layers which exist and comprise a Esri map. In this situation, you can see there are some layers representing manholes, wastewater main pipes, air valves, fire hydrant lines, that kind of thing. Now, users can, using DataSplice, download work orders to their device, go out into the field and interact with those work orders, change the statuses, create labor records, things like that. There's an advantage to having the users perform that same work and visualize it on a map. So the way that the DataSplice server enables that is by using a plugin that allows it to consume data from a service such as the one you're looking at here. This is just a development ArcGIS system that we have in-house here in Fort Collins, Colorado, and it has some information about our city. One of the layers available on this map is called hydropoly, and that represents lakes and rivers in the area. And you can see information about each hydropoly. It has a name, it has a major, it has a length and an area. And I can go ahead and make a query here, look at an example of the kind of data that is possible to fetch from this service. So I'm performing a request here, and showing up on the screen is a bunch of GIS information relating to the lakes and rivers in the area. The DataSplice server can independently make requests for such data from a GIS system at the same time that it's also making requests for Maximo data, and it can send a blend of both GIS and Maximo data to a user's device, a user who's going to be working in the field. What you can see on your screen now is a map, and there are a number of things I can do. Of course, you can zoom in and zoom out. I can toggle different kinds of base maps, and there's lots of other options here that are available. I can toggle the visibility of some of the features on my map. What has happened in advance is I've logged in as a user called Tech, and when I logged in, the server looked at who I was and what my permissions were, and it saw that I should have synced to my device a certain set of GIS features alongside Maximo data that should be synced down to my device. So I might have a bunch of assigned work orders. I might have materials and attachments and work logs and other things sent down to my device. And alongside that, I'll also have a number of different GIS layers. In this case, there's 3 layers: spans, towers, and work orders. And I'll show you during this afternoon's presentation how we would go about adding another layer and perhaps styling that. One of the key concepts I want to get across here is that DataSplice can independently consume data from these 2 sources. In the context of DataSplice, it can correlate them with one another. So in our demos that I'm showing you, the Maximo system actually doesn't know about the Esri system, and the Esri system doesn't know about the Maximo system. The 2 are unaware of each other. There may be people in the room whose companies are using Maximo Spatial, which is a way of pulling GIS data into Maximo itself. What's different here is we don't rely on there being a connection between Maximo and Esri. Maximo Spatial is not a requirement to use mapping with DataSplice. Instead, what's happened is we've independently fetched both sets of data and provided them to this user. We need one more piece of information that allows us to know how the features from the GIS dataset correlate with the assets and work orders from the Maximo dataset. So in your Maximo system, you may have work orders that are incident upon an asset, and an asset may have an asset ID. And likewise, in the GIS system, you may have these towers, as you're looking at on this screen here. These are electrical towers with electrical cables between. Each tower may have an MX asset num, for example. And we'll know that the value for the tower's MX asset num is the same as the value for the work order's asset ID. And in that way, we can know that these gray towers don't have work orders on them, and these orange ones do. Now, all of these are choices that are available for our customers to use. And at the start of a project, we'll have a conversation about the specific use cases that we're trying to cater to, the specific set of users, and we'll be thinking about the work that they're doing day in, day out, and identifying the features they'll need to help them get that work done. And we'll define in advance a set of data that should be downloaded to those users' devices to help them work disconnected with their Maximo processes, but from the perspective of a map. What I'm showing you on the map here, all of these features are being fetched from the local database that I've synced to my device, so I can go offline and still see all of my towers and spans and the work orders on them. I can interact with these features. In this case, the use case is that I'm inspecting these towers to see if there's any trees or other kind of problems encroaching on them. And if there's no problem, I can click on each tower and pass them, or I can select a group of them because I can see down the line that they're fine and pass them all in one go. Perhaps this one is not a pass. It fails because of the insulator, let's say. And everything that's happening now, the fact that I'm being prompted for information here, is a result of configuration that's set up just for this demo system. It's going to look different on a per customer basis. That discussion about what that process should look like for this set of users is what we typically do when we're working with you on a project. So we'll design that process together, and we'll use DataSplice to configure how those users ought to be able to interact with their data. I've been updating the status of work orders and assets just by interacting with the map. It's entirely possible that I can view this same 27 records as a grid and inspect them in this way. As I mentioned earlier, the only real difference between doing this and doing it on the map is that we're correlating each of these records to one of the GIS features that were fetched in advance. So if I switch back to the map, I'll now be on this feature, and you can see these additional ones were checked green. DataSplice can be used in the absence of a map, and you can go through and have users edit data, or we can, if the data exists, we can provide them access to the same data and processes in the context of a map. And we've got many customers now using DataSplice mapping in production, and there's large differences between the kinds of information that they want visualized and the way in which they want their users to interact with it. I have another one for that I could show you in another window here. This is another one. This is a wastewater basin cleaning and hydrant inspection application that's been developed here. So I can move through a data set and interact with my map, jump to specific subbasins or search by intersections or manholes, that kind of thing. So there's lots of possible capabilities that we can endow our users with, and what we give them is a result of those discussions we have with the subject matter experts who are out there doing that work in the field each day. DataSplice, perhaps.
Question here, Daniel.
Please do, yes.
Stop for a second.
Alex, and this is kind of like the real world. I'm trying to just put a perspective. So we're all online, but you have the guys in the pipelines here covering multitudes of states, or the inspectors cover 2 states. So when they go to disconnected mode with these maps, and maybe you did not cover that yet, do you use Esri to generate the disconnected map to put onto the device with DataSplice? So when they don't. So I'm just trying to get a feel how are the disconnected maps generated?
Absolutely. Absolutely. So what we'll do is we'll have a conversation towards the start of the project about what's going to happen in the real world. So for example, if you've got a very large city, you might have a scenario where crews of wastewater basin cleaning crews, for example, they might be divided up by east and west, let's say. This set of crews always work in the east part of the city. This set of crews always works in the west. If that's the case, that's an opportunity for us to say, hey, when someone logs in, we identify which type of crew they're in, and without them having to make a decision, automatically, after they've logged in, all the features they'll need to perform their work in that east side of the city are automatically synced to that user's device. Likewise for the guys working in the west side of the city. That's one scenario. Another scenario may be that it's not as regimented as that. Let's say we're talking about a different city, they've got different processes. It might not be anywhere near as regimented. The scenario in this other city might be that, yes, there's a general kind of plan A. We're going to go out and do some work that's been assigned to our crew, but it's always possible, and it's not uncommon, that you'll have to deviate from that plan and go somewhere else, perhaps to respond to a service request or to take over work from someone else. And that's normal and something we encounter all the time. So the question becomes for us then, how do we best serve those users' needs? How do we help to model your real-world business processes and set DataSplice up so that the users receive the data they need for what's realistically going to happen during their day in advance? Our goal being to ensure that at no point is a user impeded from getting their work done because they don't have the data they need. There's other ways that can manifest itself, or there's other tricks up our sleeve, I could say, for how we might do that. So I mentioned earlier that we could do it one way where a user logs in, and because of discussions that we've had with your IT team and your subject matter experts in advance, we've already identified that this is the set of data that these kinds of users need to get their work done. They'll need these 12 layers, they'll need these lookup codes, they'll need their work orders, etc. Or we might say, okay, they're going to be doing one of three things. Maybe what we can do is prompt the user when they log in to say which area you'll be working in that day, or which van or truck you'll be taking out, and have the user make a decision when they log in, and then based on that decision, based on the answer to the question, then we decide to pull down dataset A versus dataset B. Or if the dataset is not very large, and
I think we got a variation on that question, Daniel. It's not quite in the direction we're going. Hang on a second.
All right. Yep.
Basically, these I'm just talking about piping. They work a whole multi-county states that day, so they don't know. I mean, they're going up and down. Basically, is there a way? And I'm just thinking maybe we could do this. You could define pre-regions with Esri against their account, and then it can download a regional area of the detail.
Yes, absolutely. Let's see if I can demonstrate that a little bit as well. So, and that's very common. So you mentioned Esri. Here's an example of an Esri service. This is a web service, like a RESTful API, and that's the interface through which the DataSplice server fetches data from the Esri system. So the DataSplice server can make a request here to the Hydro Poly layer and fetch every single river and lake that exists in Colorado, let's say. Or, because rivers and lakes have attributes on them, maybe there's major and minor. Maybe this is a Boolean, and the lake is either a major lake or a minor lake. Well, we can make a request that includes major lakes only, for example, and fetch 500 rather than 1,000. The same thing goes if we were talking about features in a city. So we're looking here, and you can see lot lines and premises and pipes and manholes and flow direction arrows. It might be that each of those has multiple attributes on it. A manhole might have multiple attributes such as radius and type, wastewater versus stormwater, and other attributes. But one of those attributes could be the region that it's in or the zone that it's in. And so if such an attribute exists, then we can use that to our advantage and say, hey, only fetch the features that belong to this zone because we know that these users are working in this zone. If the data exists to be able to carve up sets of features in that way, we can leverage that to have different groups of people see and interact with different sets of data based on where they're going to be on a given day, or based on a permanent thing such as, you know, if you're very regimented, you might have crews that are permanently set up to specific regions or to specific types of work.
I said the region, like the way this cycle is, their region could be a half a state, or 200 miles wherever it's going through the state. That's all. But
right. Yeah, and actually for where we have very long linear, we've got a lot of customers using DataSplice for long linear assets like multi-state oil pipelines or cross-state, power distribution cables, things like that. So that's very common that we'll have to cover very large areas. But I should say that all of the features that you're seeing drawn on the map here, they're all being fetched from the local data store on my device. So in this case, the device is a web browser, and I'm sure you've already heard from other people at DataSplice today that DataSplice is a cross-platform client. You can use it on the browser, as an Android app, as an iOS app, on the Windows desktop. In all of those cases, the mechanism by which all of this data is stored offline and is rendered is identical. So the user experiences and the technologies across all of those platforms are identical. So the challenge is us really to discover up front what do these users really absolutely need to get their work done, and how do we ensure they always have access to that data. Are there any other questions there, Graham?
No questions right now, Daniel.
All right. I want to talk a little bit about the styling of these items on the map. Maybe I'll switch over to the line patrol one here. So you can see that there are these circular icons to represent things on the map. And some of them are orange, some are green, some are gray. In this case, for this demo, we've specifically decided to show the towers differently based on whether or not there's a work order on it and what the status of it might be. So if there's no work order, we've decided it's going to be a gray circle. If there is one, but it's not been done yet, it's orange, and it's a green for the pass and a red X for the fail. There's a lot of flexibility for how you use styling to transmit information to the users that are using your app. We've got customers that have multiple widths of pipe underground, and for them the most important thing is to be able to see at a glance which kind of pipe is which by differentiating them by color. So we won't necessarily use the work order status to style the pipe colors. We'll use the width, so all the 8-inch pipes will be pink and the 10-inch pipes will be blue, 12-inch pipes will be green, etc. So you have at your disposal total flexibility for using, for making decisions about how features should be styled, and it can be based on any of the data that's been synced down to the DataSplice device. So another example might be the priority of work orders. If I'm zooming out and I'm looking at a large city as an overview, I want the high priority work orders to stand out. As long as work orders have a priority attribute, we can use that to make decisions about how things are styled. Now, there might be some technically minded people in the room. I just want to give you a little look behind the scenes for how this is actually implemented. Justin, I know, just spent some time showing you a little bit of DataSplice administration. I'm connected to the system that is configuring that line patrol application with the green and orange towers right now. The DataSplice server, as you probably already had explained to you, it has a plugin based architecture whereby each plugin that exists allows it to communicate with different sources of data on your network. You can see some for databases, for Maximo, and this one here is for Esri. So this is where you'll decide which Esri services we're going to be fetching features from. I talked about the hydropoly lakes and rivers earlier. So I'm going to go ahead and add that service here. And I'll call it I'll call this one Fort Collins, because that's where we are. And I'll paste the endpoint of a different feature service into the DataSplice server. And now I've made that available for me to choose to bring new layers in. So in the same way that data from Maximo is consumed by DataSplice as a view, you've probably been looking already at work orders, for example. It's making a big select from the Maximo database. In the same way, I can define views that originated not from a database, but instead from this web service. So I might create a new view here, and I'll call it water features. And it'll be an Esri feature data source. And then the next step is to choose which service I'm connecting to, and I'll choose that newly created Fort Collins service. What will happen now is it'll show me the list of possible layers that I can use, and I'll pull in hydropoly. Now each lake I mentioned earlier or river has a number of attributes, so I can include those here. I'll include the name and just the object ID for now. And if I just check off the primary key here, at this stage I should be able to just preview some of that data directly. So what's happening now is the DataSplice server is making a request to that endpoint and fetching features for me from that service. Just waiting for those to load. Meanwhile, I'm going to come over here and show that there's only towers and spans at the moment, and then work orders. I haven't shown you the work orders part yet. What we're going to do is add those lakes to the list. So we'll just wait for that to finish doing its thing. I'm going to abandon the changes I've been making just during this demo and log out. And the reason I'm logging out is because I'm going to define new permissions that allow me to access this additional view in the DataSplice system. All right, let's take a look at that again. Okay, so I'm gonna, there's something not available on that service right now. I'm not exactly sure why. So I'm going to show you another part of this, which is everything in the DataSplice user interface, when interacted with, can be thought of as an event having happened. So when I select this tower here and I say pass, the way that that works is that in configuration we've said when this pass button's clicked, then these things should happen. And in this case, the thing that happens is we update the status of the work order to say that it's passed its inspection. There are a number of other things we could do. So here's another example, is if I was to right-click on a part of this map, a long press, that event has been configured to trigger a different chain of actions. The first action in that chain is to display this prompt, which is asking if I want to create a work order at that location. So I'll say yes. And this could have a positive or a negative outcome. The positive is the yes, the negative is the no. If I say no, the chain just stops. If I say yes, the chain continues to the next action. And the next action after the pop-up is to create a new work order displayed on my screen. And we'll notice that it's possible.
This is what we were talking about earlier and doesn't require integration at the back end with a local Esri GIS system.
Right, exactly. We're creating a feature here based on the lat long of where I touched them on the map. And that event that triggered this chain of actions can have context associated with it, like the lat long as an example. Or if the event was triggered by clicking on an existing feature, I can pre-populate the work order with attributes from that feature, such as we've done with the location here and the work type. So I can go ahead and enter some more information, perhaps look up an asset, put that on the feature, on the work order rather, assign a lead for this, Mary Jones, and then say done. And now we can see that the work order that I just created that was triggered by me long pressing on a blank spot on the map now has a visual representation. So I can see that map, that work order on the map, even though we've not fetched it as a feature from an Esri system. We're just working entirely disconnected. That work order, I can go ahead and view it again and interact with it. So the reason that it's possible for us to see that on the map is because it has a lat long associated with it. And that's why we're seeing it here. And so that's another tool that's available. It's another capability that's available to you. You can capture events that users initiate, such as when a user touches a feature on the map or presses a button or long presses on a blank spot, and you can decide what should happen after that event occurs. We want to create a new work order and associate it with that feature, or we want to create a new service request to report a pothole or whatever it might be. Or if we click on a button, then we want to perhaps perform a search or filter what I see on the map. DataSplice doesn't know in advance what those actions are going to need to be, and what happens during a DataSplice project is that our teams work together to decide what those actions and capabilities need to be for the set of users that we're trying to help. The main objective for DataSplice is to simplify and facilitate a user getting a specific job done in the field. And as we mentioned earlier, that job can be unpredictable or it can be extremely predictable and regimented. And we deal with both continuously, and that's fine. Our job is to ensure that nothing impedes that user from getting their work done, which is why, from a design perspective, DataSplice has always had an offline first approach to our technology, because we've just heard so many times that it's very frustrating and disruptive to have the status of the network prevent you from actually proceeding and getting your work done.
Quick question coming in, Daniel. Hang on a second.
Please do.
So if you're disconnected at this point and the Esri data is local and Maximo doesn't know anything about lat long, where is the information for that work order you just opened stored?
In this example, the lat long for that work order is stored in my local DataSplice database alongside all the data that I synced down originally at the start of my session. If we are to create points on the map for which there is no corresponding Esri feature, then, as you imply, we'll need somewhere to store that data later. In the case of the demo system you're seeing, there are fields in our Maximo system which were added later to just store the lat long of a work order should a work order need a lat long. And that was to satisfy this particular use case. Alternatively, though, this system isn't set up with that. Instead of clicking on a blank part of the map and taking the lat long that was a part of that event having occurred, I could instead have clicked on an existing attribute or asset from the GIS system, like one of these towers. This one has no Maximo record associated with it. Or we could say, all right, when this event occurs, the user touched a tower, we'll create a new work order and we'll populate its asset ID field with some information that came from the GIS system. So I mentioned earlier that the way that we take these two independent data sets, one from GIS, one from Maximo, and the way that we correlate them together is we know how the fields line up. The tower's MX asset num correlates with the work order's asset ID, for example. So if I was to create a chain of events that was triggered by me clicking on a tower, and one of those actions was create a new work order record, then in configuration, one of the things we'll have done is pre-populate that work order's asset ID field with the MX asset num of the tower that was clicked. In that way, the newly created work order can be uploaded to Maximo with an asset ID that correlates to the tower that was clicked when that work order was first created. So we still didn't describe any actual communication directly between the Maximo system and the Esri system there, because instead what's happened is the two data sets have been blended together in the context of DataSplice. So if I go and create another work order here, you'll notice that this work order ID field at the top is blank. It's also read-only. Obviously, I'm working disconnected. So I'm creating new work orders, but I don't have new work order IDs allocated to me by the Maximo system because I haven't communicated with the Maximo system yet. I'm just working offline. And perhaps I'm in a very remote area, and I'll be working offline for several days. During that time, I'm accumulating changes to existing records and the creation of new records. And what the DataSplice system does behind the scenes is it creates kind of a virtual work order ID, and it uses that to thread together the relationship between this newly created work order and any materials or work logs or labor entries or attachments or other things that might relate to this work order.
Thank you.
Just, thank you so much. We're going to go ahead and end the meeting now.